So a little bit of a longer problem, so just be patient as we go through the mechanics of how to work this out. One thing I'm going to have us do is we're going to expand out, sort of distribute in the parentheses, because we know how to convert y double prime and y prime and y into a power series. It's just we have that extra x plus 1 and 2 minus x, so it's just going to give us a longer process. And for right now, I am just acknowledging that I'm going to ignore that information until we get to the relevant part of the problem. So don't stress about where'd it go. No, didn't go anywhere. So if I expand this out, I get x y double plus y double minus 2y prime plus xy prime plus y equals 0. Okay, so we're going to have to do a lot of conversion here. So for the x, so the summation for the second derivative is n equals 2 to infinity c sub n of n times n minus 1 times x to the n minus 2. And that's just for this little piece right there. Okay, so then we want the, I just kind of repeat myself with the second derivative there. So n equals 2 c sub n, n minus 1, x to the n minus 2. Okay, so that's this piece right there. And then minus 2, and then the first derivative. So that's n equals 1, c sub n times x to the n minus 1. And I'm getting out of room a little bit here. Let's see. So, oh wow. Let me adjust my settings on that. Don't need a big giant pen. Okay, so that's that piece right there. And then I'm going to go below it, plus x y prime. So n equals 1 to infinity c sub n times x to the n minus 1, and yeah, that'll work. Okay, so that's this piece right here, and then plus y, which was summation n equals 0 to infinity c sub n x to the n. Okay, and us all equals 0, but just be patient with that. Okay, now a couple things I'm gonna, let's talk about those x's out front real quick. So this x right here, and that x right there. So if I essentially distribute those in, what is that going to do to the exponents? Well, I'm adding x to the, so multiplying by x, which is x to the first. So it really is going to take my exponent and add 1 to whatever's there. So the part that says x minus 2 is going to become x minus 1. And I get rid of that. And this is just going to become an n when I add 1 to that. Okay, so that's one challenge addressed. Next challenge is to do a series, so we focus on the exponent and we do our substitution based on the exponent. So this first one, I'm going to say k is going to be n minus 1, which means n is k plus 1. This next one, I'm going to say k is n minus 2, which means n is k plus 2. This third one is going to be k equals n minus 1. So n would be k plus 1. And then here I can just do a k equals n and k equals n. Okay, so that's my next phase, is to do those substitutions and see what we get. I'm going to scroll down here. Okay, so for that first term, let's see, so if I put, let me highlight which one I'm talking about. So I'm focusing just right now on this guy right here, just on that one position. Okay, so my summation, so what happens to n equals 2? If I put a 2 in for n, I get that k equals 1 to infinity. And then this becomes c sub k plus 1 times k plus 1 times k. And that becomes x to the k. Okay, so that's that first term. And in the next position, I want to swap out, let's see, so summation, same thing. I get k equals 1 to infinity, c sub k plus 2 this time, and then k plus 2 and k, let's see, k plus 1. And that's x to the k. Okay, so far I've just addressed the first two terms. And I'll bring down the minus 2. So I'm going to look at this term right here. So that's minus 2. And all right, so what's k going to equal here? So if I evaluate 1 for n, that's 1 minus 1. So k equals 0 to infinity. C sub k plus 1 times n, which is k plus 1 times x to the k power. All right, 2 more to go, and then we can have another conversation. Oops, I'm a little off screen there. All right, so then I'm on this term right here. So that's going to be, I'm just doing a straight swap. So k equals 1 to infinity. C sub k times k times x to the k. And then the very last one, so I'm doing this term right here, summation, oops. I'm sure that symbol's much better than the first one I wrote. So that's k equals 0 to infinity. C sub k, x to the k.